What's up, guys? So, on the transformation quick guide here, this is what we're working on. We're doing Pglo lab today. We're actually doing the lab, conducting the class. These are the little foam things that we're using. These hold your test tubes. And so they go down in here, and where the test tube sticks out the bottom, that's where it's going to be either submerged in the ice water bath or the hot water bath. I'm going to give the guys that are here a quick overview. And you people at home who are conducting this lab, you're just going to follow along, and then we will post data on the discussion board for day, what day are we on right now, 16? We'll post results tomorrow or the next day, and you guys at home that are working through this lab can use that data to complete the lab, okay? So if you're following along here with the Pglo transformation quick guide, which I posted for you guys on Schoology, here's the basics. You're going to get a couple of these little test tubes. You're going to label them. One's going to have Pglo in it. One's not. One will be positive that has the Pglo. The other will be negative. You're going to open them and you're going to transfer some transformation solution. So I'm going to have transformation solutions up here for the different groups. Each group should be able to get their own bottle. The transformation solution, all it is some calcium carbonate, and it's going to be basically just a sterile solution for your bacteria to kind of hang out in, okay? Good. You're going to place the tubes on ice. So you're going to take one of the beakers. There's some smaller beakers around, probably at different stations. If you'll just take that, fill it about half full of ice and water, and leave yourself a little bit of room at the top, maybe an inch or so, and then just put your test tube rack down in there where the tubes are submerged in the ice. The fourth thing, you're going to, it says use a sterile loop to pick up a single colony of bacteria. Normally a single colony of bacteria is round. You can see it, you can pick it up. We've got more of what's called a lawn going on with you guys that are growing back there, which means basically they're kind of growing all over the plate. I'm not super concerned with just getting one bacteria and transforming it, or one colony. To make sure we get some bacteria, what I want you to do is to gently, you'll rake your inoculating loop back and forth all over the top of that Petri dish, and we'll see. We want as many bacteria as we can get. I kind of made a mistake when we were pouring these. I had Caitlin pour them for me a couple days ago, and I kind of rushed her, and we didn't pour them thick enough. And so some of them dried out. So I think you should have enough where you can just rake it along the top. If yours is completely dried out and cracked, like one of the ones at the beginning of school this morning, then let me know, and we may have to, you may have to share a starter plate with someone else, okay? So basically what you're doing in number 4 is you're just getting your bacteria that you started yesterday, okay? That you started growing on the plate. Number 5, this is where you're adding the plasmid. So the plasmid that contains the gene from the jellyfish for the bacteria to fluoresce, you're going to add it to the Pglo positive test tube, okay? You'll come up and get that from me when you're ready. I'll make sure you get enough on there. You'll add it to that one test tube. You'll also notice in here it says you're putting it on ice. Number 6, incubate tubes on ice. It says 10 minutes. Unfortunately, because of our very short period, let's change that to 8. I don't think it's going to have a huge effect on it, but this will save us a little time and make sure we get finished by the end of the class period. On number 7, those of you out there doing this for giggles on your own, I would stick to protocol though. Number 7, you're going to get these plates. I'm going to have them up here. You're going to get 4 of them. You get 2 LB plates. Or the 2 LB amp plates, you're going to get one with just LB and one with LB amp and arabinose. Did we talk about what this meant yesterday? Yeah. I want to make sure you know what it means. Write it down if you don't. LB is the Loria broth. Broth meaning it's something in that gel for the bacteria to eat and grow. The LB and the amp is the ampicillin. This is like, think penicillin. It's a antibiotic, so it should kill bacteria, okay? If it has AMP in it, in those gels, it means it has an antibiotic. LB, AMP, and arabinose has all 3 of these. Arabinose is a sugar which is needed for that fluorescent gene to be expressed. So it has to have that arabinose sugar in order for it to fluoresce or glow. Okay? So in number 7, you're going to get those. You're going to label those either plus or minus, the ones that says Number 8, once your 8 minutes is up, you are going to go to the hot water bath. There are hot water baths set up in the back, so one of y'all will share one of those, but you're only going to have them in there for 50 seconds exactly. So this is for maximum efficiency of transformation. So you need to carry, once you take your 8 minutes out of the ice water bath, take them over there, set your clock 50 seconds in there, take it out, and you're going to go back and incubate in the ice for 2 more minutes, okay? Number 9, it says remove the rack from the ice, and then you're going to add some lauria broth, which will mean some more nutritive solution for the bacteria. You're going to do that for 8 minutes, which we're going to change that one to 8 as well, okay? And then number 10, that's where you're going to apply your bacteria, either your ones you've exposed to the plasmid and the ones you haven't. That's when you're going to add them to the new Petri dishes that you have, okay? So you're going to add them on there. You're going to use an inoculating loop, one of those yellow loops, to basically wipe them back and forth like we talked about yesterday, where you do one way, you turn it diagonal and do another, and you do another, and so you're basically smearing bacteria all over the Petri dish. When you're through, you're going to stack them upside down. You see how they're stacked upside down like that? I think one of the problems last night is the moisture in the agar dried out and it condensed when it got hot and went to the top of the plate. And so if we flip them upside down, that moisture is going to stay on top with the agar, and hopefully they won't dry out and there'll be more bacterial growth. And you will put them, just stack them up, make sure your name's on one of them. Put the arabinose one on top because that's the one we're really probably most concerned with. And stack them upside down together nice and neat in the incubator, and we'll see what happens in the next day or two. Okay? Any questions? So like I said, you got some times here where you're going to have to be waiting for stuff. Now, those times which you're waiting, you need to be reading ahead, making sure you're ready, and then you can also work on the Megabucks lab where you're looking to see who the father of those babies were. And then on the back side of that, there is a sheet that asks you to figure out, there's a mix-up at a hospital, there's 3 parents, there's 3 kids, they mix their babies up, and you've got to figure out, using that DNA, whose baby goes with which set of parents. So you and your partners can work on that during some of those time periods that you're waiting, okay? Any question? Get your gloves, get your goggles, and let's get going. We're short on time. Go. Apparently none of y'all read this. Gloves, goggles, lab, be ready.